Welcome to EDU World Space.
So here we want to find the volumetric flow rate for the pipe. We'll say that the larger diameter section of the pipe will be 1 or subscript 1, and then subscript 2 would be used for the smaller diameter section of the pipe. So we can say that we're essentially going to be using the equation of continuity and then using the Bernoulli's equation after. So we can first say that the volumetric flow rate through both sections is equal to one another. My apologies, A sub 2, V sub 2. And we can then solve for the V sub 2, the V sub 2 equaling A sub 1, V sub 1 divided by A sub 2, the cross-sectional area of the smaller section. And we can say that V sub 2 is then going to be equal to V sub 1 times pi r sub 1 squared divided by pi r sub 2 squared. We're going to cancel out the pi. And we simply have that V2 is equaling V sub 1 times r sub 1 divided by r sub 2 quantity squared. After this, we can then use Bernoulli's equation and say that atmospheric pressure plus the pressure in the first section plus 1/2 times the density times V sub 1 squared plus the density rho times G Y sub 1. This will equal the atmospheric pressure once again plus P sub 2 plus 1/2 rho, the density V sub 2 squared plus rho G Y sub 2. We know that from the heights they're going to be the same for both of the sections. So this term cancels out with one another on either side. And then the atmospheric pressure, of course, cancels out. And at this point, we can say that P sub 1 plus 1/2 times rho V sub 1 squared equals P sub 2 plus 1/2 rho V sub 2 squared. And we can then substitute for V sub 2, and this is going to equal P sub 2 plus 1/2 rho. And then for V sub 2, we'll say V sub 1 times R sub 1. Rather, we'll say V sub 1, and then in parentheses R sub 1 divided by R sub 2 quantity squared. And this entire thing is going to be squared. So at this point, we can then say that P sub 1 plus 1/2 of rho V sub 1 squared. This is going to equal P sub 2 plus 1/2 rho V sub 1 squared, R sub 1 to the 4th divided by R sub 2 to the 4th. And at this point, we can solve for V sub 1. So V sub 1 is going to be equal to 2 times P sub 1 minus P sub 2, and then this will be divided by rho times R sub 1 to the 4th divided by R sub 2 to the 4th minus 1, and then this entire the entire equation to the 1/2 power. And at this point, we can then, if this is the formula for V sub 1, we can then find the volumetric flow rate. A sub 1 V sub 1 equals pi R sub 1 squared, and then again times the square root of 2 times P sub 1 minus P sub 2 divided by rho, the density, R sub 1 to the 4th divided by R sub 2 to the 4th minus 1, and then we can just solve. So this will be A sub 1, V sub 1 would be equal to pi, and then times 0.03 meters squared times the square root of 2 times 32 minus 24 times 10 to the third pascals. And then this will be divided by the density, 1,000 kilograms per cubic meter, times 0.03 to the fourth, divided by 0.0225 to the fourth, and then again minus 1. And we have that the volumetric flow rate is going to be equal to 7.7 times 10 to the negative third cubic meters per second. And so this will be our final answer. That is the end of the solution. Thank you for watching.